All right, so next up, we're talking about extrema of functions of two variables. And so I went ahead and drew a picture that's kind of a graph that's shown on page 885 of your textbook. And here's the x coordinate, here's the y coordinate, and then up and down is the z coordinate. And what I've drawn is the surface z equal to f of xy. And just so that you know what I was trying to draw, in these two quadrants right here, kind of imagine mounds like for a sandcastle. And then in these two quadrants of the XY plane, imagine like big ball pits. And the surface has both of these peaks and these valleys. And then the surface is just sort of everything in between that kind of connects those things. And I kind of tried to shade that in so you could see that the surface exists everywhere. It's just the distinguishing features are these high points and low points. And this one back here is also just the same as this pit up here, just harder to draw with the perspective. So the reason I drew this is because it has a lot of examples of extrema, which is going to help us kind of learn what these things are. So extrema are the collection of maxima and minima of a function. Maxima and minima are plurals of maximum and minimum. If you just want to say maximums and minimums, that's fine. I'll probably do it sometimes too. And when we're talking about maxima and minima, we have to distinguish between absolute and relative. So we're going to have the idea of relative or local maxima, and that just means that these are places where the value of the function is higher than anywhere else around it. So larger value of f of xy than anything nearby. And so examples of this would be right here at the top of this peak and right here at the top of this peak. I'll denote with star right there. So these stars are local or relative maxima. If you're at the top of this peak, anywhere you go nearby you is smaller. So right here is a local maximum. But you're not an absolute maximum because you're not bigger than anything anywhere. Cool, that thing is right there today. An absolute maxima would be larger than any other f of xy for all xy. So if one of these two peaks was taller than the other, maybe this one's at 10 and this one's at 8, then the one at 10 would be the absolute maximum because it's taller than anything else anywhere on your surface. Yep, okay, so then relative or local minima have smaller value of f of xy than anything nearby. And so that's going to be down at the bottom of these two valleys, kind of. If you're at the bottom of this pit, then any direction you go from here is going to be higher than the very bottom of the pit. But they're only relative or local because there's another pit somewhere else in all of xy that could be lower than the other. And then the absolute minima would refer to something that's smaller than anything else. And so again, if this one was down here at minus 10 and this one was down here at minus 15, then this would be the absolute minimum. Because not only is it smaller than anything nearby it, but it's smaller than any other value on this surface. So something can be both an absolute and relative minimum. See, this point right here is a relative minimum. It's smaller than everything around it, but it's also an absolute minimum. It's smaller than that other point over there. Something can be only a relative or an absolute maximum or minimum. This point is a relative minimum because it's a relative maximum because it's bigger than everything nearby, but it's not absolutely maximum because this other value far away is bigger. And it's going to bother me that this is not next to the name, so we're just going to fix that real quick. And so hopefully this picture kind of helps you recognize the difference between relative and absolute maximums and minimums. And I left a little bit of space here because there's one other type of important point that we're going to talk about, but it's kind of unfamiliar to you. So we're going to introduce the necessity of that point first. Let's make sure I have time to show you all these steps. Okay, in the next video, I'll show you the steps for identifying these maximums and minimums.